Welcome back, you deep divers. Today we're setting our sights on a topic that's not just fundamental, but absolutely electrifying for anyone on their journey to becoming an airline pilot. Gas turbine ignition systems. It's a core piece of engineering that, well, quite literally gets these incredible machines to fire up and keep flying safely. Understanding it deeply is, frankly, non-negotiable.
Yeah, absolutely. And what's truly fascinating here, I think, is that we're not simply going to walk you through how these systems work. Our mission today is really to peel back the layers.
Yeah.
We want to uncover the core principles, the ingenious design choices, and the critical operational details.
Right.
This isn't just about preparing you to answer questions on paper. It's about empowering you with the kind of conceptual mastery that makes those sometimes quite challenging ATPL theory questions feel more intuitive, giving you that decisive edge.
Exactly.
So yeah, this deep dive is really tailor-made to ensure you walk away not just with knowledge, but with an unshakable clarity on exactly what you need to remember and integrate into your understanding.
Our mission today, then, is to really break down the what, the how, and maybe most importantly, the why behind these sophisticated systems. We're going to extract the most important nuggets of knowledge from your sources. We'll focus first on the foundational general principles that govern, well, all gas turbine ignition. Then we'll take a deep dive into the intricate internal workings of the high-energy ignition unit itself. That HEIU sounds quite impressive. After that, a look at the different types of igniter plugs that do the actual sparking.
The business end, so to speak.
Exactly. And crucially, throughout all of this, we'll be connecting the dots so you understand precisely what this all means for you, especially when those ATPL questions demand, precision and a deep conceptual grasp.
And if we connect this to the bigger picture, truly mastering these ignition systems is absolutely fundamental. It's just core knowledge. It's about ensuring safe engine operation in all conditions, right? From a frosty morning start to, navigating a thunderstorm.
Right.
The details we'll cover aren't just theoretical fluff. They are frequently tested concepts because they represent critical operational knowledge. Things you need to know. So let's get ready to build a solid foundation, one that'll serve you exceptionally well, both in your exams and, throughout your future career in the cockpit.
Okay, let's do it. Section 1, the foundations of gas turbine ignition general principles. Let's kick off with the very foundations, looking at the general principles that apply across the board. And here's where it gets really interesting right from the start. I found this quite striking. Every single gas turbine engine you'll ever encounter, without exception, comes equipped with a dual ignition system. Not just one, but two independent systems.
Yeah.
And crucially, they all utilize high-energy igniter units for the initial engine starting phase. So the big question is, why two? And why high energy?
That's precisely the critical question, isn't it? And it speaks volumes about the priorities in aviation design. Why dual? Well, it's fundamentally about redundancy and reliability, especially during the most critical phase of engine operation.
The start. Makes sense.
Imagine the consequences if an engine failed to ignite when you needed it to, whether it's for a scheduled departure or potentially even more critical, an in-flight restart.
Yeah, absolutely.
Having two completely independent systems provides that essential layer of backup. It significantly increases the probability of a successful engine light-off. The system can even tolerate a single failure, usually, and still perform its primary function.
Okay, redundancy. That covers the dual part. What about the energy level? High energy HE. Why so much power just to start?
Right, the high energy part. For these initial starting units, the HE output is precisely around 12 joules. Now, that might sound like just a technical detail.
12 joules, okay.
But think of it as a precisely calibrated miniature lightning strike. It's a significant, concentrated burst of electrical energy. It's designed to reliably initiate combustion in what can be a pretty challenging environment. Cold, dense air, fuel vapor, high airflow inside the combustion chamber.
Right, needs a good kick.
Exactly. It has to overcome substantial resistance.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.